Yeah, so in the de Moivre's theorem, firstly we have to define z. So we know z can be defined as x plus iy. Also we can write z as r cis theta. If you expand it, that would be r cos theta plus I sin theta, and then this r is common for both of these. Now this is how you define a complex number in Cartesian form and in polar form. Now what is de Moivre's theorem? So if you want to find z to the power n, and that would be r cis theta to the power n. Now if you consider this individually, so this is going to be r to the power n and cis theta, the whole thing, to the power n. So the de Moivre's theorem is saying that r to the power n, this n is absorbed here, so then it would be cis n theta. So this is what is happening in de Moivre's theorem. You are going to absorb the power inside the system. So now we'll discuss few small examples. If you want to find z to the power 2, right, so you can say r squared. So this would be originally cis theta squared. So this 2 is absorbed here, so it's going to be r squared cis 2 theta. And if you want to find z to the power 4, this is going to be r to the power 4 cis 4 theta. And if you want to find z to the power minus 1, so this is going to be r to the power minus 1 cis minus theta, right? So this is going to be 1 divided by r cis minus theta. And in general, if you want to find z to the power minus k, so it's going to be 1 divided by r to the power k cis minus k theta. Okay, so what you have to do is here you have to find z bar. So first of all, we have to look how z looks like. You expand it, so cos theta plus I sin theta. So that means if you want to get conjugate, that would be r cos theta minus I sin theta. So what I will do, I will absorb this one inside, so that would be r cos theta, you can make it plus I sin minus theta. Now we know that cos theta is equal to cos minus theta. Why? Because cos is a even function, so I can say r cos minus theta plus I sin minus theta. Then I can say this is nothing but r cis minus theta. So z bar conjugate would be r cis minus theta. Okay, so now here we are given z and z bar, so we need to find the multiplication. So let me write z here. Z would be r cis theta, and z bar is r cis minus theta. Okay, so what I'm asking you to do is z bar, which is r squared cis theta times cis minus theta. So this is what we need to do. So I will keep r squared here. Now I will expand cis theta. So that would be cos theta plus I sin theta, and that is going to be multiplied with cos minus theta. So cos minus theta is cos theta. So I will just leave it as cos theta minus, sorry, plus I sin theta minus theta here. So what I can do, this minus I can absorb here. So what I can write, r squared cos theta plus I sin theta. Then here I get cos theta minus I sin theta, because sin theta is an odd function, so we can take minus outside. Cos theta is a even function, so that's why I didn't put minus here. So now if you look at this, and if you simplify, cos with cos is going to be cos squared theta, cos with I sin theta, it's going to be minus I cos theta sin theta. Then I with this, it's going to be plus I sin theta cos theta. Then I with I is going to be minus 1 with minus 1 is going to be plus sin squared theta. Then this guy is going to cancel with the other one. So you know you have cos squared theta plus sin squared theta, which is 1. So the answer is r squared. So in this question, we have to simplify this form. First of all, 1 plus I, we have to convert this into polar form. So what you do, you take the coefficients and then square it and take the square root, and that would be square root 2. So 1 divided by square root 2 plus 1 divided by square root 2 I. So this is going to be square root 2, you can say cosine pi divided by 4, because 1 divided by square root 2, that is very easy, the first quadrant, plus I sine pi divided by 4. So this is nothing but square root 2 cis pi divided by 4. This is my first equation. Then the next one would be 1 minus square root 3i. Here my r value would be 2. So I'm going to divide 1 by 2 minus square root 3 divided by 2 times I. So now we know that this is the cos term and this should be the sine term. So sine is negative, cos is positive, and that would be this quadrant. So cosine, what value gives you half? So if you do cosine minus pi divided by 3, which is half, and sine minus pi divided by 3, which is minus sine pi divided by 3. Why? It's a odd function, so it's going to be minus square root 3 divided by 2. Good. So what we do is, to here cosine minus pi divided by 3 here, and plus I sine minus pi divided by 3 here. So now what you have here is 2 cis minus pi divided by 3. So that is, this is form of the denominator. So now I have 1 plus I to the power 3. So I'm going to use the de Moivre's theorem. So this is what I have. I'm going to rewrite here. So 1 minus square root 3i, the whole thing to the power 5. So 1 plus I would be this, and the whole thing to the power 3, it's going to be 2 square root raised to the power 3, and cis pi divided by 4 raised to the power 3 divided by, this one is to the power 5, the denominator, so 2 to the power 5 cis minus pi divided by 3, the whole thing to the power 5. Now what we can do, we can absorb this one inside using de Moivre's theorem. Now it's going to be 2, 3 divided by 2 divided by 2 raised to the power 5 cis 3 pi divided by 4 whole thing divided by cis minus 5 pi divided by 3. Now this is what we have so far. Now we know that if you want to divide two cis values, right, so what we know in theory, so if you have cis theta 1 divided by cis theta 2, that would be cis theta 1 minus theta 2. So that's the theory. So if I apply that theory over here, so I can write this 2 to the power 3 divided by 2. So I'm not going to touch that. Here cis 3 pi divided by 4 minus of 5 pi divided by 3. So now we have to simplify this. Now so if I do this one, so 2 to the power 3 divided by 2 minus 5, so I take it up, and cis 3 pi divided by 4 plus 5 pi divided by 3. Then what I have here, I have 2, so 2 to the power 2 times 5 is 10, so 3 minus 10 is 7, so it's going to be minus 7 divided by 2 here. Now cis, I have to get the common denominator, that would be 12, so this is going to be 9 pi, and this is going to be 20 pi. So what I will get finally, 1 divided by 2, 7 divided by 2 says 29 pi divided by 12, right? So we get this one now. But finally, what is cis 29 pi divided by 12? So that would be 1 divided by 2 raised to the power 7 divided by 2. So this can be written as 2 pi plus 5 pi divided by 12. So we know the circular function theory, 2 pi plus angle would be the same angle. So this can be written as 1 divided by 2 raised to the power 7 divided by 2 is cis of 5 pi divided by 12. And that's the answer to this question by using the polar form. Essentially we have to use the polar form for this. Why? Because if you can if you see the complex number given 1 plus I raised to the power 3 and the other one is raised to the power 5, you can see you have to definitely use the de Moivre's theorem. So to use the de Moivre's theorem, you have to convert any complex number into the polar form.